Get out. You finished 3-6. Get it out. Oh. Should probably do that attendance thing. That one's here, 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 that one's here. That one's said they would be gone. Here, 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 here. Sweet. Okay, starting with, we check before we check. Check your work, make sure that you got everything solid before we do our daily check. We had time in class. Pretty much everyone said that this was easy peasy. It was just a matter of keep that cheater, I'm writing over here on the board here, keep that cheater in mind. If I have y equals x plus c versus y equals x minus h squared plus k. Suppose they like to put c for this one, but I'm going to put k just so we understand that it's the same whether it's line or quadratic. That is my vertical translation, up and down regular town. And does everyone remember what inside the grouping does? Who's got that little cheater? Left to right, and because it's grouped in with the x, bass-ackwards land. Remember, it always does the opposite. Like, if grandma gives you $100 for your birthday and you're saving up for, I don't know, new console, new PC, something, the goal gets closer. Plus 100 meant I went this way 100 with my goal. Okay, so it has opposite effect. So I'm going to leave those cheaters there, and we're going to add another one next to it, and you're going to see, hopefully today, it's the exact same thing. Literally, if you got last class stuff, today's a breeze. Even the White 4 crew, who's a little rambunctious, shall we say, they finished with like 15 minutes left of nothing. Okay, work and all. So I think we're going to be good today. Make sure, we cool? As long as you got those cheaters. On backside. Oh no, we did. Oh, that was completely the wrong thing. There we go. So we started in here. We didn't have much, right? Like 10 problems? Good? Okay. Each of these was just describing that translation. Did y'all catch that they're messing with you on 14? They just wrote it backwards? If I just swap the order, then it should look a little bit more familiar. Y'all know that you can do as weird as you want with these. Like I could say y is x minus pi over 3 squared plus 15 root of 6 over 11. I could do something dumb like that, and, well, it's negative and it's in the grouping. Which way do I go? Okay, in the grouping is bass-ackwards, and because, or sorry, left to right, and because it's in the grouping, it's bass-ackwards, so negative means I'm going right, whatever pi over 3 is, plus big ugly number. It's outside the grouping, so up or down. If it says plus number.
Up.
Up. Okay? Whatever the numbers are. Below that. Well. Okay, this time they were giving you the parent and telling you the transformation. You had to write the equation, the other. So every other time they give you the equation, tell me transformations. Now it's, here's the transformations, you tell me the equation. So it was backwards. Okay. The model of the word problem was just blah, 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 do the exact same thing. Vocab. And a couple of us asked, said, could I do this with this transformation business? Could I just move it up or down and that's it? And turns out, because this is here, I can't. What that does is it creates a stretch. It'll take that normal y equals x graph, it'll move it up 3, but then it stretches it twice as tall. Okay, stretch. Now we're not going to deal too much with those, they're called dilations, but this is just the introduction. Okay, so, I would like for you to do 3-6. Here you go. Daily check, somewhere in the back. You don't even have to graph them. You just tell me, for both of those, what's the parent function? What'd they do to it? What's the parent function? What'd they do to it? Okay? Should be pretty quick. Then have yourselves ready to go for 3-7. Should be relatively quick. Still give you another couple minutes though.
I do this one, I just keep it up and down.
You tell me.
Oh, so what you would do both of them though? Both of the sides?
Since there's a number in both spots, you will have two different transformations to say for that one. Yes, ma'am. Just bring it over whenever you're ready.
Yes, good.
Fancy pants. That's how you make sure that your cards don't go flying all over your truck.
I mean, yeah.
You can choose one. Eli will finish white and move on to the other.
Okay.
There's 100,000 magic cards in this room right now. Rylan took most of those and the middle schoolers, but I'd say we still probably got about 1,000 or so. There's a lot more. Okay, does anyone need more time? Okay. No, not there. So what we should have is the first one, parent. Now you could either say y equals x, because that's the parent equation, but if you had instead said a line or the identity function, all three of those mean the same thing. Well, they're talking about the same thing, just in a different context. Okay? Some of us might say, hi, Drace, how you doing? Some of us might say, sup, butthead? Grandma might say, hey, moon pie. Okay, it depends on the context, right? It's still him. Moon pie. Okay, I'm just going to keep using that as an example until one of you starts calling one of your buddies moon pie. Okay. You could have said, any of those, tell me, what does this do to it? Is it inside or outside parentheses? I don't see any parentheses up there at all, so it's outside. And if it's outside, that's the up-down business, and it's regular sign, so I would say I shifted it down 17 units. If you just said down 17, I got one kid in White 4 who is adamant that they have to use arrows all the time. They just don't want to write words. All right, as long as we can tell where you're going. Contestant 2. What is that called? The parent function. Okay, so I could have said y equals x squared. I heard someone else say it's a quadratic function. Do you remember what the graph is called? Parabola. Okay, so again, you could have said any of those, and I'm cool with it. There were two transformations made to this because there were two different numbers stacked in with the x squared. Just like the last one, this minus 12 is outside the grouping. So that tells me down 12 units. but the 11 is inside the grouping, so that's left, right, and it says plus 11, so left 11. Just like if I'm saving up to do a thing and my buddy pays me back $11 for getting him lunch once or twice, my goal is closer. It moves this way. Okay? So I'm going to go left 11 units. And you notice there's 5 things up there. You told me what it was. You got it. You got it. You got it. You told me what it was. 5 things, 5 points. Yes, ma'am.
So, like, would I get 2 points off if I didn't say if it was a line or a quadratic for either?
Yeah?
Alright.
Because that was half the directions. State the parent function. Okay? So, did y'all think that that was an easy lesson? Or at least a reasonable lesson? If you think that was okay, 3-7 should be a breeze. Right? You had a day off last Wednesday. So, open up 3-7, absolute value. I know you've seen this thing before. Does anyone remember what it means? When I put bars on either side of it. Okay. Ooh. We don't have our normal blank space here. Do it up in the top here. We should have room. Frank, don't you start with me? Okay. So absolute value is there we go. Absolute value is a very simple concept. If it is, you know what? Let's compare something here. Who thinks they live the furthest away from the school on those nice compacted icy roads? Grace? Whitewood? Okay. Anyone got that beat? Ooh. Sturgis?
Kind of further away from the sawmill.
Okay, the sawmill, I mean, it's still, if you go out that way, it's still like, it's in the region. I think it might be out of city limits once you get past the sawmill. But Whitewood is still, what, 8 miles?
4 miles.
10? Oh, and then if you're on the other side of it, yeah. Okay, so you even got me beat. I'm outside of Bell on the south side. That's about 11 miles, like door to door. Now think about this. If it's 11 miles from my house to the school, is it negative 11 miles from the school to my house?
No.
Like, can you drive negative 11 miles? You got that one pedantic jerk who's like, bet. No. Okay? Do you remember getting like, maybe you did Pythagorean theorem back in elementary, middle school? And if you ever got like, this is 3, this is 4, and then you got a -5 here, you just know you screwed up, right? You can't have a negative length, right? I can't say that someone is -4 feet tall unless I'm just insulting them. Like, it's not possible to have a negative length. That's what absolute value is. It's distance. Specifically, distance from 0. So you probably remembered this, if you remembered it at all, you probably remembered it as always positive. Because if I say the absolute value of 4, you put two like big straight line brackets on either side of it. How far away from 0 is 4? Well, 4, right? 1, 2, 3, 4. I count 1, 2, 3, 4 units away from 0. But if I ask what is the absolute value of -4, how far away from 0 is -4? It's still 4, right? 1, 2, 3, 4. Here's -4. I still count 1, 2, 3, 4 spaces. So the answer is still 4. It's kind of like that I am Groot thing all over again, where the answer is always positive. Or maybe, teenagers, maybe this is the toxic positivity from parents or a teacher or something who says, oh no, you just have to have a good attitude. And you're like, ha ha, my existence says otherwise, right? Always positive. That's what it means, always positive. So if I plug in a 5 and a -5, I'm still going to get 5. Where it gets funky is when I have more than one thing possible because there's a variable in it. Now I'm saying x is 4 units away from 0. Well, what's 4 units away from 0? And 4 is 4 units away from 0. What else is? -4. So we get this idea that when there's a variable in there, we've got the light side and the dark side where they have cookies. Okay? It could have been in 2 different places. I don't know because I don't know what x is. So absolute value is distance. Distance has to be positive. If it has to be positive, that's going to take all these lines we've been graphing and it's going to bend them. Okay, take a peek at the very first example where they ask us to graph this. If I were to use my good old table here and have -3, -2, -1, 0, 1, 2, 3. If I dealt with just absolute value of x, the parent function, y equals absolute value of x, tell me, how far away from 0 is 0? Cool. How far away from 0 is 1? Is 2? Is 3? You're like, man, we should do this kind of math all the time. What's the absolute value of -1? How far from 0 is it? 1, 2, 3. So what happens is I'll get this line, but then when I come back the other direction, I go to -1, and normally if we're doing a line, it would go down -1, right? But absolute value says, turn that frown upside down. Must be positive. And I come over here to -2, and I would go down here, it says, nope, positive. I'd go to -3 normally, y equals -3. Okay, it's down here, and then I'd say, nope, must be positive. It takes that line, this is the line we're used to, right? It cuts it off right there and flips it up here instead because distance can't be negative. Now, I can move the entire thing up, down, right, and left when I'm done with it. So now, check out what they want us to do. They want the absolute value of x plus 1. So I would take this parent graph, I would take all those points and just add 1 onto them. 4, 3, 2, 1, 2, 3, 4. I'm going to take this parent function and all the points on it and just like we were talking about last time, I'm going to move it up 1. Okay? I'm taking the parent graph and moving it up 1 because look at where the 1 is. Is it inside the grouping or outside the grouping? Okay? So also, here, we did this, what was it, 1 unit up? So also up at the top or wherever you got space where you can like big neon highlight, this is really, 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 really important. Y equals absolute value of x minus h plus k, just like it is over here. H is left, right, bass-backwards land. K is up, down, regular land. Okay? I'm going to take that V, and I'm going to move that V left or right, up or down. Okay? Now I already got this one written. Just chill. You can do it, Frank. So my parent function is always going to have a vertex at hk because I'm going to move that point left or right, up or down. On the right-hand side and the left-hand side, the slope is going to be 1 over 1, or mirrored across, a negative 1 over 1. Remember our slopes. This says up 1, right 1, 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 up 1, right 1. Look at it. Up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. But because I'm not allowed to make it a line, it's got to hinge up into a V. On the left-hand side, normally I would go down 1, right 1, but I'm starting right here, so I'm going to have to reverse my flow. This is why I spend so much time pounding on that, is we're going to call it up and left. Left 1, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, up 1. You see those slopes of 1 and negative 1. So I'm going to take this parent graph and I'm just going to keep moving it up and down and left and right. Up and down and left and right. On the right side, slope is 1. Mirror it to the other side, slope is negative 1. So now I feel like it was better to start with that than straight for the throat like this. Look at their equation. We're going to take this graph and I see plus 1 in the grouping. Left or right? To the left, to the left. So I'm going to take this and move it over here. I see minus 2 outside the grouping. Up or down? So the V is going to start here. I'll make my first dot there. Then on the right side, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And instead of connecting the dots to make a line, I'm going to mirror them to make a V. Up 1, left 1. Up 1, left 1, up 1, left 1, up 1, left 1. Okay? So you're just taking that V and moving it up, down, right, and left. And that's it. Okay. I will write that same stuff over here. We'll add it to the others. Now it's y is absolute value of x minus h plus k. And I hope for those of us who are more concerned about our digital balls that we're going to be writing this down. Okay. Digital. Okay. So flip it over. We're going to look at that cheater. I see -1 in the grouping. Up, down, right, or left. Okay, I heard down, right, and up. Look at your cheater. Inside the grouping is left, right. It's bass-ackwards land. So this is right. 1 unit right. Look at the cheater. Well, it's not the cheater, it's your notes. Okay. -2 is outside the grouping. Look at your notes. -2 outside the grouping means what? So I'm going to go 2 units down. That means this dot that would have been right smack in the middle of the graph at 0, 0, I'm going to move it right 1, down 2. And then I'm going to start my V. The V always has a slope of 1 on the right side. We're going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. And you might just have the muscle memory right now of grab a straight edge and, but no. Go back down to that vertex and hinge that stuff up into a V. Mirror across that axis of symmetry, I'm going to go up 1, left 1. Up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Connect the dots and you should get a V. Now some kids get upset, maybe just pedantic, that, well, it's not a V, like you can see more of the left side than the right side. It's like a check mark.
It's a backwards check mark.
Like, have you ever played a video game that has the map in the corner? Y'all, what would happen if I just took this map and I moved my graph, my area of viewing a little bit to the right? Then it would be perfectly a V. It's just, this is how much of it I can see. Okay? If I were to continue making boxes, and made just one more dot, oh hey, now it's a V. Okay? So some of them are going to look more like check marks than the absolute value V, but that is the right idea. All right. Graph them and tell me what you're doing. 1 and 2, go. You just move the point of that V, called a vertex. You're going to move it left or right, up or down. Watch the scale.
So where do you start?
Well, normally we always start at 0, 0. You just said you're going to go 5 units. Bass backwards town, dude. So I'm gonna go 1, 2, 3, 4, 5. And then my V is always up 1 over 1 on this side. Always. The only time it changes is when we start putting numbers in front of it. And we're not going to see that at all in this lesson.
Okay.
That's just like the slope on that side.
So we're just.
So then up 1, over 1. Up 1 over 1, up 1 over 1, up 1 over 1.
And this one just.
Mirror the other way. Up 1, left 1. Yeah. That's it. We're keeping the slopes on the left and right sides are going to be plus or minus 1 for this entire section. Okay, we're trying to keep that part simple so that we can focus on the transformations. Dude, right there.
Yeah. So.
Is that 5 inside or outside the grouping?
Inside.
Plus or minus.
Minus.
So what does minus in grouping do?
Right.
Okay. You're going to go 5 units right. So the point of your V, the vertex, goes right 5. And then the slope on this side is always going to be up 1 over 1. Yeah, they're going by 2s. So you're going to have to count half a box at a time. Now, mirror it the other way. Up 1, left 1. Here's them.
It's kind of correct. Because I tried.
Yes, no, we just missed our scale.
Yeah.
Your vertex is in the right spot.
Yeah, it's just, I know that's
You
like
BS the lines. You only put 2 points on there. Child. Up 1 over 1, yes.
Okay.
Up 1 over 1. Up 1 over 1. Up 1 over 1.
I hate the big stuff.
Okay. Now I heard, you are not the first person to say this, I hate itty bitty dots. I hate counting by 1s on a scale of 2. Y'all, we saw this with our graphs. If the scale is by 2, couldn't you just multiply that and turn it into up 2, right 2? It's still the same proportion. So it's inside the grouping and it says minus. We're headed to the right. 5 units right. So I start here, and whether I'm using up 1, right 1, 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 or if you don't like that, buff it up to a 2 over 2. Go up 2, left 2. 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 When you're done, it should be symmetric. Y'all remember doing symmetry in middle school? Where you'd get like a picture of a butterfly or something like that, and you'd have to find the dotted line down the middle that it folds over. Ooh, I might be showing my age here. Has anyone ever worked with a mirror? Mirror. Okay. A mirror. Come on. Frank. Close enough. A mirror kind of looks, it's made out of like a colored but see-through plastic. And it kind of looks like a really tiny I-beam. Like this. And I'd set it down next to a picture. So my picture would look like this. And when I put it next to it, because of the beveled surface in it, it creates a reflection on one side or the other. if I put this on this side and I look at it this way, to my eyes, it looks like there's a picture on the other side, and I'm able to trace that phantom picture like this. And it's just this little chunk of like see-through plastic that you put on there. Anyone ever use something like that? No? I mean, they're fun to work with. I used them in art and geometry. But contestant 2, up, down, right, or left? Frank, you cross-eyed redneck inbred piece. 2 units up. And again, I can choose to use a slope of 1, or I can double it to a slope of 2. And then mirror across that invisible line that goes through my vertex. Connect dots, get V. I saw some of your graphs use a straight edge. You know who you are. That looks atrocious. Use a straight edge. Okay. Go to the next side. Uh-oh, now there's 2 of them. There's 2 transformations. I'm just going to write them both. -6 inside the grouping. Look inside the grouping. What does minus do? I go 6 units right, because it's bass-backwards land. And I see a -1 outside the grouping. So I will move 1 unit down. That means my very first point that would have been at 0, 0, I'm going to move it over 1, 2, 3, 4, 5, 6, down 1. So it's almost covering up 6. And whatever your vertex is, the slope on the left and right is still plus or minus 1. So from here, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Or you could go up to left 2. You could just double your scale. It just changes how many points you have. As long as I've got enough to see where my V goes, as long as I've got enough to trace with straight edge, we're good. These transformations are a pretty big deal when you get further up in math. If you got any friends in Algebra 2, at the end of every single chapter, we beat these to death. Like, at the end of every Algebra 2 chapter, we do transformations of whatever function we were just learning. Okay, up, down, right, and left. It does not change no matter how complex the math gets. How do we feel? Like, okay, you are going to come back and do this. I want to do the words. Because we always freak out when we see words. But then we read the words, and they say, the point at which an absolute value function changes direction is called the vertex. Y'all remember those from like middle school geometry, right? The pointy parts of a figure are called vertices. This is plural for vertex. Well, it should make sense that it's a vertex because it's a bunch of V's, just whichever direction they are. Oh, it just says, where's that vertex? I will move bass-backwards down, left 3, regular down 6, left 3, down 6. It's in a weird place, but I can still count. up 2 over 2, up 2 over 2, up 2 over 2, or maybe I go up 4 over 4. Whatever my scale is, that 1 to 1 can be scaled up or down. Or 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, whether you want to do a lot of little dots or you want to space them out some more. Larshi. Okay, fairly straightforward. I told you it's not too bad. If you notice, it's also the last section in the packet. So, I'll give you time to work this off. I'm going to get the next packet ready for Wednesday. Okay?
Sorry, you don't have to. I wouldn't want to make you do all that work.
All right. You got time to work and when, pause.
Are we doing progress check 3 or not?
Don't cross it out, but I'm not requiring it right now. All right. You finish this off. I get the next packet ready. Please ask questions if you're not sure, though. What? See, now I'm not, no, I ain't gonna do this mom, can I, dad, can I business,